Now it's your turn. Pause the video. Get your copybook, the square paper, your pencil, and a ruler. Try to graph those given functions. Hopefully you did it all correctly. Now you can check your answers. Check each point here in the graph. Compare them with your answer. Inshallah, you did them all correct. Again, pause the video and graph those functions. I can give you some hints. Here, the y-intercept would be the 2. Okay. Use table of values. Use a square paper. Graph it. Here, number 4, the y-intercept would be 10. It would be a large number, and then all the numbers would be smaller than this one. Here is the graph. As we said earlier, the y-intercept here is 2. You might use 1 point less than 0, 1 negative value for x to know the path of the graph. All the values now after for the positive values of x are very tiny and very close to the x-axis. Here, as we said, the y-intercept is 10. We're using here a different scale. Each block represents 2 units. So you can plot the points here. And then we use several points after the y-intercept. You join them. Again, the graph approaches toward the x-axis and never crossing it. It's all above the x-axis. Now let's start the third example, example number 3. And you might recall the translation which explained in 8.1. When we add or subtract a certain value to the x values, this is causing a horizontal translation. And as mentioned before, as we explained in 8.12 in the previous tutorial, when you subtract a certain value from x, it means this function is going to be shifted to the right. When you subtract, the graph is translating to the right, and when you add, the graph is translating to the left. Here in this particular example, we subtracted 2 from the power. It means the graph is shifted 2 units to the right. Okay? Now, I'll start doing this, and then I will show you the accurate graph. As usual, we start by graphing the basic function before the transformation. So I'm graphing y equals half to the power x, and I'm using a table of values here. X and y, when x, I'm assuming several values for x. When x is equal -2, you can use the calculator. Y would be 4. When x is equal -1, it is 2. The y-intercept when x is equal 0 is always 1 in this case. 1 corresponds with half. 2 is quarter. You might add another value. When x is 3, it would be 1/8. Now, I'll start sketching the basic function before the translation. I'm trying to make my graph as accurate as possible, but of course, without having a square paper, it wouldn't be accurate like yours, but I'm going to show you the accurate one. Now, I'll start plotting the points. I'm using the blue for the original one. -2 corresponds with 4. 1, 2, 3, 4. -1 corresponds with -2 with 2, sorry. -1 with 2 here. The y-intercept 0 and 1. 1 and half. Then 2 with quarter. 8, very, very small. The values are getting very small and very closer to the x-axis. My graph is going to go along the x-axis. I'm joining them with a smooth curve like this. Now, as we said earlier, this -2, this subtraction is causing a horizontal translation to the right. It means I'm going to shift all the points to the right 2 units. Let's start with this one. I'm starting with the y-intercept, the most important point. I'll use another color here, the red one. This 0, 1, I'm shifting it 2 units to the right. I'm getting my new point. Another point you might also translate this one, which is 2 and negative 2 and 4. I would translate it 2 units to the right, 1, 2, it would be here. Now I can join my new points with a smooth curve again, approaches toward the x-axis, and falling down from left to right. About the horizontal asymptotes, as mentioned earlier in 8.1, horizontal translation never affects the asymptote. The asymptote stays the same, which is the x-axis with equation y equals to 0. This is the asymptote. For the domain and range, again, also in horizontal translation, the domain and range stay the same. The domain is always all real numbers. This uppercase of R represent all real numbers. You might use your own words, writing all real numbers is the domain. Another notation you might find in your tasks, in your assignment, you can say that x is greater than negative infinity and less than infinity. It means that the graph extends from negative infinity to infinity. It covers all real numbers. This is just another notation to express all real numbers. About the range, since the whole graph is above the y-axis, above the asymptote, so it is greater than 0. It is above y equals 0, which is the range y greater than 0. Let's see the accurate graph. Here, again, this is the blue one. This is the y-intercept. We shifted it 2 units. Instead of 0, 1, it became 2, 1. This one, negative 2, 4, became 0, 4. The whole graph is shifted to the right. The domain, all real numbers. The range, y greater than 0. The horizontal asymptote is the x-axis. With equation y equals to 0. Now the next example, example number 4, graph y equals 2 over 3 to the power x plus 3. Again, you might need to recall this plus 3 outside the function. When you add or subtract value to the function from outside, like here, this is causing a vertical translation. When you add, it shifts up. When you subtract, it shifts down. Again, as usual, I will start my graphing with graphing the basic function y equals 2 over 3 to the power x. I'm graphing the original one before the transformation. I'll use table of values, several values for x and several values for y. If x is negative 2, negative 1, 0, 1, 2, and 3. I assumed several values for x. I will use the calculator, substitute x for negative 2. It would be 2 over 3 to the power negative 2, which is, I'll use another color. I prefer the blue for the original one, as in the textbook. When you substitute x equals negative 2, it would give you 9 over 4. As a decimal, this is 2.25. When x is equal negative 3, it is 3 over 2, which is 1.5. 0, of course, is the y-intercept, which is not written. It means it is 1. When x is equal 1, 2 over 3 to the power 1 remains as it is, which is with decimal form 0.67. When x is equal 2, it is 4 over 9, which is 0.4. I assume those are enough values. Let's now start sketching the graph. Here are my axes. I will make it a little bit equal distance between the units. I'm trying my best to make it clearer for you, but I will show you the correct graph. Now I'll start plotting with the blue color the original basic function before the transformation. Negative 2 corresponds with 2 1/4 above. Here is 2, it's 2 1/4, a little bit above the 2. Here is the negative 2 with 2.25. 3 over 2, negative 1 correspond with 1 1/2, half the way here between 1 and 2. 0 with 1. 1 with the 0.67 above the half. 2 with 0.4 below the half. And as you keep putting values, it would be very close to the x-axis. You don't really need to find all those points. You just need points to be like a guide for you. And of course, you know, in the original basic function before transformation, the x-axis is the horizontal asymptote. The graph falls all above this line. Now I'm going to translate everything 3 units. As a guide for you, I would prefer to start by shifting the asymptote itself 3 units. This asymptote, I'm going to use another color, the red one. This asymptote is going to be shifted 1, 2, 3 units. It is here. Here is your new asymptote, which is y equals 3. And this is actually part of the question. He's asking you to describe the horizontal asymptote. It has an equation. Describe means find its equation, and plot it in your graph. Y equals 3. This is my new asymptote. Okay, now I will shift everything 3 units up. This y-intercept, it would be 1, 2, 3. Here is my new y-intercept. This point also would be 1, 2, 3. It would be here. You can shift the points, and then you would get your graph. Join it with a smooth curve. Remember, the asymptote, the new horizontal asymptote, is like a boundary into your graph. Your graph should go along this line, but never intersect it, never crosses it. Here is the new graph after shifting the asymptote 3 units up. This red dotted line is the new asymptote y equals 3. And also, all the points are shifted up 3 units. So for the horizontal asymptote, it would be y equals 3. For this domain and range, the domain is all real numbers, while the range is affected in vertical translation. As mentioned before in the previous tutorial, we said that the domain remains the same for all exponential functions, whether it's growth or decay, translated up, translated down, left or right. The domain is always real, all real numbers. But for the range, since you shifted the whole graph above this line, y equals 3, then the range would be y greater than 3. The whole graph here, as you can see, is above this new asymptote, so the range is y greater than 3. Here is the accurate graph. The blue one is the original, the basic one before the transformation. We shifted everything up. Here is the new asymptote, y equals 3. And again, the domain remains the same, all real numbers. The range is y greater than 3. Now it's your turn. Try to get your square paper, your pencil, a ruler, and try to graph this one, putting in your mind that adding 3 to the exponent means this graph is going to be shifted 3 units to the left. And here is the correct graph. You might need to check your point, your graph. Inshallah, you all did it correctly. For the domain, it's all real numbers. For the range, y greater than 0. Again, I'm repeating over and over. Horizontal translation never affects the domain and range. They always are the same. The domain, all real numbers. The range, y greater than 0. Because the graph here is all above y equals 0, which is the x-axis. Next one, checkpoint number 10. Y equals 1/3 to the power x plus 3. As a hint for you, this 3 is causing a vertical translation 3 units up. Try to do it and come back and check your answer. Again, here is the correct graph. A new asymptote here is graph. This is dotted line. It is y equals 3 because everything is shifted 3 units up. And the graph goes along this new asymptote. It means the domain, as usual, all real numbers from negative infinity to infinity, while the range, since the graph here is all above this line, the range is y greater than 3. Several questions, or this type of question you might find in your assignment, which graph matches this equation. Given an equation 2 times 2 to the power x minus 1, and given several graphs, and you have to decide which graph matches this equation. You actually decide upon two things. First of all, you have to decide whether it's a growth or a decay. Looking at the base here is greater than 1, so it is a growth. It means I'm choosing from those two growth graphs, and I'm excluding the decay one. Now, the second thing to decide accordingly is the shifting or the translation. Is the function here, we subtracted 1, negative 1. It means the function translated down 1 unit. And which of those two growth functions is shifted down 1 unit? Of course, this is the correct one. Another question you might find in your assignment, which equation matches this graph? Given a graph and given two functions or two equations, he wants you to decide which one represents this graph. Look at the graph carefully. It's falling down from left to right, so it is a decay. Yes, sure. Then you would choose the one with base less than 1 because this one represents a decay. Again, given a function, it's required to match it with the graph. Again, you have to decide whether it's a growth or a decay first. Since the base here is less than 1, so it is a decay. So you would exclude any growth function. This growth one will not be in my answers. I have two here, decay. How to decide now? You decide according to the translation. Plus 4, it means the graph is shifted up 4 units. So it means this one is also not my answer, and this one should be the correct answer. The graph here is a decay with base less than 1 and shifted up 4 units. That's all for today's lesson. Hopefully, you understood all the concepts in this lesson. Please check your homework, which is uploaded in your drive. Submit your assignment on time. And until we meet again, stay safe.